Hey guys, we're going to talk about sum and difference equations. So everything we've worked with so far has been, here's a perfect right angle, and we can figure out that for sine of theta. So we're going to talk about what if we get a triangle that's not perfect, or how did our calculator figure out this perfect angle? So over time, we created what's called perfect triangles. So like 30, 60, 90, and then we found out the ratios that way. Over time, though, we had to figure out triangles where it was 53, 47, 90. And so how we did that was we created these things called sum equations. And what sum equations are is the basic idea of let's combine two things we know to find something that we don't. So for example, let's say that we had a triangle that was 15 degrees. Well, a basic one that's on our unit circle is 45, and another one on our unit circle is 30. And so if we subtract these two, we could get to 15 degrees. So we would take the sine of 45 and the sine of 30, and then figure out what the sine of 15 is from there. So we have a couple equations that help us figure that out. The first one we're going to start with is cosine, and this is the symbol alpha minus beta. So whatever our first angle is minus our second angle. So for our previous example, it's 45 minus 30. The equation is cosine of alpha times the cosine of beta plus sine of alpha times sine of beta. I know that's a lot, but this was how we programmed our calculator to figuring out cosine of 45 minus 30 gets us to cosine of 15. So you can plug this into your calculator and just get it. We're trying to understand how our calculator functions and how the coding of it works. So let's do an example in which it's 60 and 45. So cosine of 60 minus 45 is cosine of 15. So I plug that into my calculator and I get 9.6. So on this side, cosine of 60 times the cosine of 45. Before calculators were invented, cosine of 60 would be on my unit circle, and I would see it's 1/2. And then cosine of 45 is root 2 over 2, which is the same as root 2 over 4, because 1 times root 2 and 2 times 2. Then on the other side, sine of 60 times sine of 45, again using my unit circle. Sine of 60 is root 3 over 2 times sine of 45, which is root 2 over 2, which gets me root 3 times root 2, which is root 6 over 4, and I plugged that into my calculator, and I got 9.6. So before calculators were invented, this would have been the furthest that they could have gone. But this is how we started our process as a society to getting to cosine of 15. Okay, here are all of our sum and difference formulas. What I would do is I would pause the video, write this on that same paper for your test, so you have all of them. So this is if we want to add two things together, so like 30 plus 30 to get to 60, subtracting, okay? So pause this video. Okay, so a question that they could ask is, given that sine alpha is in quad 1 and sine beta is in quad 2, what is cosine of alpha and beta added together? So what that means is for sine alpha, it is in quad 1. So that means there's a triangle in quad 1. And then alpha. And sine means opposite over hypotenuse, which means to find this other side, I would do my Pythagorean theorem. And I would solve for b. And I would find that I would get the square root of 16, which means that b is either positive or negative 4. Because it's in quad 1, it must be positive 4. Then we would do the same thing for sine beta. It says it's in quad 2. And then sine means opposite over hypotenuse. I'm going to do my Pythagorean theorem again. And when I solve for b, I get the square root of 144. So it's either going to be plus or minus 12. And because it's in the second quadrant, this is negative 12. Okay? So it asked for cosine plus alpha and beta. So our equation for that is cosine of alpha times cosine of beta minus sine of alpha times sine of beta. So cosine of alpha would be adjacent over hypotenuse. Cosine of beta would mean adjacent over hypotenuse. And those are going to get multiplied together. And then I'm going to have minus sine of alpha, which is opposite over hypotenuse, times sine of beta, opposite over hypotenuse. So I multiply these together, and then subtract. And when I do so, I get negative 63 over 65.